Now how to do this? I'm gonna go to mate. And the first mate ever is that this circle should be in the same plane as the circle. Alright, so they should be in the same plane. Now how they should be in the same plane? I know that I drew these two circles in the front plane. So what I'm gonna do is to select the first face and go here, select the front plane. Why is it not working, guys? Do you know why? Because in fact, this is the first gear. Alright, and don't forget that the first gear is always, the first component in mates will be always fixed. So that's why I'm gonna flop it now. Then I'm gonna go back to mate. Then I'm gonna select the front plane, the face, and now it will turn, and then they will be coincident, right? Then I'm gonna click OK, and do it the same for the second gear. So this gear with the front plane, and then I'm gonna click on OK. Alright, guys. So now they are in the front plane. They are both in the front plane. Alright? Now what I'm gonna do is to select this circle here. So let's make this circle and let's make it concentric with the circle. Alright? And I'm gonna click OK and do the same for the second gear. So now, guys, they are concentric with their pitch circle. Now, guys, I'm gonna close the mate and adjust the teeth so that they are within the teeth. How? First of all, let's go to front and click on normal 2, zoom it, and then rotate the second gear so that the teeth are not in a contact. In a contact, there will be some clearance between them. But now, guys, I'm sure that they could be in meshing before doing the advanced mate. So guys, as you can see, this is the pitch circle, alright? And these two pitch circles are tangent. Now what I'm gonna do is to go to this mate. So let's go to mate, go to the mechanical mates, and select the gears. So whenever, guys, you select the gears, you have to select this to make some selections. Now, what you have to do, guys, in the mate selections for gear is to select the shaft circle for both gears. So this is the first circle and this is the second circle. Automatically, Solidworks will take the diameter of these two shaft circles, but this is not, in fact, the ratio, the velocity ratio. I know that the velocity ratio is d over d, the diameter over the diameter, or omega over omega, or the radius over the radius, or the number of teeth over the number of teeth. Alright? So guys, in fact, I should adjust it. What is the ratio here? It's the first diameter over the second diameter. If you want a reverse or an opposite velocity ratio, 80 over 100, you have to select on reverse. It depends what you select first. So if you select the circle first, you have to put 100 over 80. If you select the circle here, you have to put 80 over 100, or you can put 100 over 80 and then click on reverse. So I'm gonna click now OK, click opposite, and then as you can see, guys, so if you rotate the circle, the second circle will rotate in opposite and by keeping the meshing. Guys, if the module is not correct, and I'm gonna show you how, if the module was not the same, you will not have a meshing gears. Alright, so if you go here, for example, and edit the toolbox component, edit the module, and make it different than the first module, than the module of the second gear, for example 2, and then click OK. First of all, there will not be engaged because it will not be, this will not be the pitch circles, they are not tangent, and second, you're not gonna have a meshing gear. So I'm gonna readjust it again. So it's 4. And click on OK. Now what if, guys, in your gear mate, you did not put the velocity ratio as it should be? In this case, let's try it. Let's make it 100 over 50. In this case, guys, you're gonna have non-meshing. So if you rotate this one, as you can see, guys, the teeth are not engaged together, right? So there will not be any meshing, right? So that's why I have to make sure that the velocity ratio is correct. So I'm gonna go here, edit feature, and put it 100/80, and then click on OK. And then as you can see, if you rotate the first one, just 1 minute, then the second one will rotate in matching. So the gears are now engaged. Now, if I want to save it as an animation, I should use what is called motion analysis, and this is the third part of the course. How to do the motion analysis? You have to make sure that you have meshed gears, engaged gears, and then you have to go to motion study here. Whenever you click on it, you can put a motor. Did you see this motor? So you can put a motor, let's say on the input shaft. Let's say the input shaft is on the gear, on the largest gear. So you can click on this one and specify the angular velocity that you want. Now here we have 100 RPM. Let's keep it 100 RPM. All right. And then you click OK. You click here, calculate. And then you can save your animation, save animation. I'm gonna save it on desktop and show you how it will work. All right. And I'm gonna call it simple gears assembly. And then I'm gonna click OK. And then I'm gonna click yes. So now it's saved. Then if I go to my desktop, and then I can click open with Windows Media Player. Then as you can see, guys, you now have your gears animation. Thank you.